As I was saying before I was interrupted, we're going to be getting as triggy as you're going to get all year long in the next couple of days. We did do a lot of trig in forces, but because our components were always right-angled components, Ty, I was able to give you stupid shortcuts. 2 lines is sine of cosinus. I could do that. Here, we're going to have to be doing a lot of very careful, not necessarily intuitive vector diagrams. And that's going to start Monday. Because of that, and because they're almost all going to be non-right angles, and because although you can do them by breaking everything up into components, it becomes really cumbersome, like 12 lines worth of work, I'm really going to push you to getting good at using the sine law and the cosine law. Both of them are on your formula sheet on the same page where it has all the other little math hints. I think there's sine and cosine and Pythagoras and other stuff. So, let's practice non-right angled trig. What do I mean by non-right angled trig? There's no right angle. In the diagrams that you'll be drawing, it'll be pretty obvious. Most of your triangles will look something like this, and you'll be solving kind of those things. So you'll clue in, hey, I can't use SOHCAHTOA. I have to use the sine law and the cosine law. Example 1 says, solve for C. Okay. First question, am I going to use the sine law or the cosine law? And you should be able to tell in less than 1 second if you know the trick. So looking at this, Brendan, what? How do you know it's the sine law and not the cosine law? Okay, you ready? Of course, Mr. Dewick has some tricks of the trade. Whenever you give me a right-angled triangle, the first thing that I do is in my mind, I crisscross it with lines. I draw a line from this angle to that side. Don't draw this, just watch. I draw a line from this angle to that side. Come on, I changed colors, Mr. Dewick. From this angle to that side. I draw a line from this angle to that side. Can you just imagine that? If on any one of those lines I have a pair, I know both the angle and the side, sine law. The green line, I know both the angle and the side, sine law. Compare that with this one here. I don't have a pair, don't know both of them. I don't have a pair, I don't know both of them. I don't have a pair, I don't know both of them. It's going to be cosine law. It's that quick. Oh, and I know it's not SOHCAHTOA because there's no right angle. So I guess, Robbie, I got to add that little mental step. But it's usually pretty obvious. Can't use the no right angle. Okay. So as a little note, we use the sine law when we have, if I just write down a pair, do you understand what I mean? You zip, 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 where you know both an angle and the side across from it. Sine law. There's our pair. This is how we're going to start it with this pair. What do we want to find? Side C. The sine law says this. The sine of the angle that you know, what is the angle that I know? 48 divided by the one across from it. There's my pair. Equals any other pair. I guess since I want to find side C, I'm going to use angle C across from it. Equals the sine of 72 all over little c. That's the sine law. Pairs equal pairs is really how I've always memorized it over the years. Oh, by the way, you could have the signs on the bottom. You could go 6.2 over sine 48 equals little c over sine 72. It's the same thing. In fact, we're going to solve this by cross-multiplying, sort of. I'm going to multiply the c to there, the 6.2 to there, and I think, Ty, I'm going to divide the sine 48 to there. Can we do that in one step, Robbie? We've gone far enough, I think. Is that all right? I have your permission? The c is going to be there. It's going to be 6.2 sine 72 divided by sine 48. You want to make sure you're all in degrees, and I do encourage you, practice typing this in on your calculator so you can see how you need to type it. I always put the number in front of the trig function because on my calculator, if I put the number after the trig function, if I'm not careful, it'll end up in the brackets. So on my calculator, I always go 6.2 sine 72 and close off the bracket divided by sine 48. Close off the bracket. How big is side C? 7.93. Okay. Is that all right? Yep. What did I say? 7.93? Yeah. Centimeters, I guess. Having said that, you're not going to use the sine law to find a side very often. You will use the sine law to find an angle fairly often, in which case you would get the sine theta by itself and then shift sine the decimal. We'll do one like that in a bit. Solve for side C. It's cosine law. How do I know? If you want to be, Julie, a bit more specific than that, I know I use the cosine law if, y'all want to look up for a second, I have two sides and the angle between them, and I'm trying to find what's across. In geometry, we used to say if you have a side, an angle, and a side, and the angle is between them, so we would write it as SAS. That's a cosine law. But honestly, Sarah, no pair. I always check for sine law first. Also, because sine law is the easiest one out of the two to use. It's less typing. It's really math 8 cross multiplying, really. So, what's the cosine law? On your formula sheet, what does it say? Does it have the c squared by itself or the a squared by itself? Okay. The cosine law says this. C squared equals a squared plus b squared. It starts out like Pythagoras, but Pythagoras only works for a right angle triangle. This is not a right angle triangle, and so we have to add a bit of a fudge factor. I always say the cosine law is a Pythagoras triangle that's been stepped on and bent, and the stepped on bending it does this, minus 2ab cos c. I really have never memorized it that way. If you want the pattern, don't write this down. You can just watch. Let's suppose I had a side little a, different letters, little q, little r, and little s, and I wanted to find r. It would look like this. R squared, big R, q squared plus s squared minus 2qs cos. What I remember is these two letters are always the same. The small letter is the side, the big letter is the angle across from it. There's my pair. It's just that in this case, I don't know the pair. So if you're wondering how to put the cosine law together, I always know the angle across from what I'm trying to find. And then it's squared, squared, minus 2 times cos. It is on your formula sheet, so you don't need to memorize it. It's just you might have put a little a right there. Oh, it would be a squared equals b squared plus c squared minus 2bc cos a. Whatever you need to get by itself. Meanwhile, let's plug and chug. C squared is going to be, what side little a? 6.2. Honestly, you can really butcher this. You could put an 8.4 in for A as long as you were consistent, and you'd put a 6.2 in for B. The cosine law is pretty forgiving as long as you get little c and big C right. The rest kind of takes care of itself. So 6.2 squared plus 8.4 squared minus 2, 6.2, 8.4 cosine of 65. I don't know why I suddenly started writing down there. Let's try that again. Computer's slowing down. I think I'm getting a new one by the end of the year. I hope. Let's do this, Mr. Dewick. And for some reason, the 5 didn't show up. There we go. And you can, if you got a good calculator, I've gone on a rant occasionally, type this all in one fell swoop. 6.2 squared plus 8.4 squared minus 2 times 6.2 times 8.4 cos 65 equals. Most common mistake, kids think that's C. What have we, yeah, I heard it, what? Yeah, we found C squared. Most common mistake by far Kids forget to take the square root. By the way, the cosine law is what you're going to use to solve about 90% of our collisions at angles. This is going to end up being a cosine law question. Yes? Where did I get 65 from? The angle? Is it 65 on your sheet? Can you read it? Oh, okay. I was hoping you could read it. I had trouble getting all the fonts and everything in. These are harder to make in Word than you realize. So, square root. C equals 8.06. Centimeters, again. You can also find an angle using the cosine law. What you would have to do is rewrite this to get cos C by itself, and then you'd go shift cos of the final answer. We'll do one like that. Solve for theta. Sine law or cosine law? How do you know? I very quickly went, hey, right there, there's my pair. So it's going to be sine of what I know divided by the side associated with it, the one across from it, equals sine of the mystery angle divided by 14.6. I can't get theta by itself. I can get sine theta by itself. I'm going to times the 14.6 over. I'm going to end up with sine theta equals 14.6 sine 51 divided by 12.3. And when I type this into my calculator, 14.6 sine 51 divided by 12.3, I get a decimal. That's not the answer. That's the sine of theta. How do I figure out what theta is? Shift or inverse or second function, whatever it is on your calculator. Arc sine if you're British. And I get 67.3 degrees. Theta equals 67.3 degrees. Example 4, sine law or cosine law? Cosine law, okay? Here's how I put the cosine law together. Kayla, what variable are they asking me to find? So it's going to be little x squared, and it's going to be cos of angle big X, the 38. And it's going to be the other side squared plus the other side squared minus 278. 119 cosine big X. That's kind of how, cosine, I can even put in the number. What was the number? 38. So I've never actually, quote unquote, memorized the cosine law formula. I just know I do the bookends in my head first, and then it's squared minus 2 times cos. Don't forget to square root. What do you get? Square root. 74.9? Yeah. I'm into centimeters for some reason. Okay. By the way, now that I know that X is 74.9, now I do have a pair. So if I wanted to find the angles, use the sine law. Or can I? There's a problem. I will say in physics, because I'll be picking my triangles carefully, you will always be able to use the sine law, I think. In real quote-unquote math, the sine law has a glitch. There's a problem. We call it the ambiguous case. So I wrote down here in this triangle, if angle A is 21 degrees, let's fill that in my picture. 21 degrees. If side BC is 8 meters, so that's 8. Hey, I got a pair. It is sine law. If side AC is 15 meters, it wants me to find angle B. Okay. Well, I would go like this. I would go sine 21 over 8 equals the sine of angle B over 15. You may be good enough, because I've taught you formula manipulation, Sam, to go from this line. You may in your head say, oh, I'm going to times the 15 over. You may be comfortable going straight to your calculator, 15 sine 21 divided by 8, and then going shift sine of that answer. And why is this a garbage answer? Yeah. It's clearly bigger than 42 degrees. See, here's the problem. On your calculator, can you find the sine of 150 degrees? You get 0.5, I believe, yes? Mm-hmm. Find the sine of 30 degrees. And your calculator, by default, assumes you're looking for the smaller answer. In other words, if you go shift sine of 0.5, it's not going to give you the 150. It's always going to give you the 30. Always. Yeah.
So it's giving you the opposite side. So
no, it's giving you what's called the principal angle. Have you guys done the cast rule yet? Okay, it's giving you the angle in quadrant 1. It will by default. Actually, that's not quite right. It's going to give you, by default, the angle in quadrant 4 or quadrant 1, depending on whether it's negative or positive. And it actually all depends on which trig function.
So it would be 180 minus that.
Can do that, or honestly, if you want a rule of thumb, first of all, here's the nice thing. Almost none of our collisions will look like this. Most of our collisions, they'll glance off each other, which means your thetas will be fairly small, less than 90. You can use the sine law. But my rule of thumb is if I notice that theta is bigger than 90, I use the cosine law to find theta, which we're going to do in a second. Because the cosine law does not have an ambiguous case. Find the cosine of 150. You get a negative answer, and if you go shift cos of that, you will get the 150 back. Now, cosine law doesn't work for angles that are bigger than 180, but those won't happen in a triangle. Those can happen in math when you're doing the cast rule and all that stuff, but since we're in our real world with triangles got to add to 180. You're not going to have an angle bigger than 180. So how do you use the cosine law? Well, like this. Oh, by the way, angle B equals, let's go back to the previous page. We haven't found angle B yet. The cosine law would say this. What's the angle that I want to find? Angle what? But what letter did I label it with on the triangle? Okay, so I'm going to imagine little b squared equals little a squared plus little c squared minus 2ac cos b. Can you see, James, again? I bookended it. The letters on the end of the cosine law have to match. Little b, big. I want to find big B. I better start with little b. I can then get this by itself. How? Well, the b squared would drop down like a domino. How would I move the a squared and the c squared over? Minus them. And that would give me, don't write this down, just look. That would give me a negative 2ac cos B. How would I move the negative 2ac over? Divide. By the way, the most common mistake, kids want to plus those over because there's a negative in front, but it's multiplying. So here is, and that will give you theta if you carefully type that in and then go shift cos. So if I carefully type in bracket little b squared, that's 15 squared, minus 8 squared minus Oh, I don't know side C, do I? Ha! I didn't give it to you. I forgot to give it to you. Let's do the next one. Sorry. I was here Boxing Day making this up. Give me a break. Which also means, by the way, because I did the answer key on one piece of paper showing as little work as possible, there's a very good chance that in my answers there may be some mistakes. I was trying to be careful, but okay. The other time you use the cosine law, by the way, is when you have three sides and no pair. If you want to, you could say when you also have side, side, side. But I just know if there's no pair, it's not the sine law. The only other thing we got is the cosine law. So, what angle do I want to find? Theta. What side goes with theta? The 12. So when I bookend things, the cosine law is going to look like this. 12 squared, and over here it's going to be cos theta. And it's going to equal to 10 squared plus 7 squared minus 2, 10, 7 cos theta. This tie is how the cosine law fits. Why memorize all the letters when you can just spot the pattern? It's way easier to keep track of. I need to get the cos theta by itself. The 12 squared drops down like a domino. I would minus the 10 squared over. I would minus the 7 squared over. I would divide by the negative 2 times 10 times 7. That's what equals the cosine of theta. Now, if you get really good at this one, for what it's worth, the cosine law will always work for finding theta. So in Nevada, every year I get a few kids that get so good at the cosine law, they never even bother using the sine law to find angle theta, even though the sine law also works and is easier. It's just their way of always avoiding that ambiguous case. Having said that, there's only going to be a couple of questions in the homework and none on the test where theta is going to be bigger than 90. What do you get? I'm going to go 12 squared minus 10 squared minus 7 squared divided by, close bracket, negative 2 times 10 times 7. You're trying this on your calculator, Ty? Thank you. And then shift cos of that. Almost a 90-degree angle, but not quite, which looks about right. It does look like almost a 90-degree angle, but not quite. I get 87, you know what? 88 degrees, I guess, if I round off properly. Okay. Is that okay? That's a really quick review of what you guys probably spent several days doing in Math 11. But I want to just give you lots of practice. So, lots of sine law, cosine law, questions. Towards the end, I'm asking you to find everything. Find all the missing angles. By the way, you only ever need to find two angles. The third one, you can go 180 minus minus, and that'll get you the third one, right? So, kick butt. You got the class to work on this.